guys. In this video, I would like to explain about testing the significance of the correlation coefficient in Python. And you know that we have done multiple videos about the correlation analysis, correlation coefficient theoretically, as well as we have done some videos in or in Python that how we can calculate correlation coefficient, uh, how we can calculate correlation coefficient in Python. Specifically, we have not done a video that how we can test the significance. We have done there, but that was not in detail. That was just the output of the correlation analysis. So today in this video, I would like to explain that how this procedure works. What is meant by the significant correlation? If you are interested to see those videos, to know about details about the correlation analysis, the links to those videos is given in the description of this video, both in R and Python. So you can go click and watch those videos to know better about the correlation analysis and the correlation coefficient, because this is very important. If you want to analyze using the correlation analysis and correlation, you have a value of the correlation coefficient. And if you don't know about the details about the correlation coefficient, you will be unable to interpret the results. That's very important to know. And the more important thing is this step is the next step. So if you know about the correlation coefficient, you know how to calculate, you know the interpretation. The next step is to test the significance of the correlation coefficient. So if you don't know, please go and click on those videos, watch those videos, and then you will be able to do and understand this step. Normally, we in hypothesis testing, we assume that we have some assumptions, some claims. Like here, you can see rho represent population correlation coefficient. It's not, we denote the null hypothesis. And this means that the null hypothesis state that there is no correlation. Rho equal to 0, this means two variables have no correlation. The alternative hypothesis say that no, the correlation is not 0. So these are totally opposite hypotheses, and this is important to note that these two hypotheses should be opposite, because if these two hypotheses are not opposite, then there will be contradiction, to draw a conclusion. So, and one thing other, we are testing about the population correlation coefficient that it is equal to 0 based on the sample correlation coefficient. And I will explain a little more about sample and population. If you are interested to test whether the correlation between students who study BE statistics, the correlation between their co-curricular activities and CGPA is 0. So this is your claim, and you're talking about worldwide, or you're talking about specific country, maybe the United States, or maybe the European Union, or maybe China or Australia, whatever. So whatever is your domain, still domain, suppose this is European Union, and you are testing the correlation coefficient between the co-curricular activities and CGPA, and you assume this is 0. So this is your null hypothesis, this one. An alternative hypothesis automatically set, because this is equal to 0, this is not equal to 0 automatically. Now you need to collect the data. So all the students in the European Union who are studying BE statistic is your population now. And maybe if you are a student, maybe you don't have resources to collect the data from all the students around the European Union. You will have some samples from different countries, 5 to 10 students, 20 or 100 students from each country, and then that is your sample. And you need to test the correlation coefficient between the two variables, the co-curricular activities and the CGPA, or the population based on the sample data. You need to test this correlation based on this sample data. I will do some videos on samples and population, because these are the important concept, parameter statistic and these things. These are very important. Okay, now I will show you that how you can see. Look at this one. So I just searched this one and I got this. This is Introductory Business Statistics, second edition, and this is the topic. This is the same thing there, the null hypothesis, the alternative hypothesis, and then the test statistic is very important. So this is the test statistic you have. The statistic is equal to R, the correlation coefficient, minus 1 minus R square, square of the correlation coefficient divided by N minus 2. N is the total number of observation. R, you can use this statistic or this one, both give you the same results. So you have the statistic. You need to decide about the significance level as well. This means like alpha is equal to 0.05. Normally we use this, but depending on your problem, you can choose different one as well. So you can see that here it is explained clearly. If the significance level is this one, and remember that this is a student t test statistic, it is mentioned here, and you can see it is here. So degree of freedom is because this is the parameter in the t test. Alpha is equal to this one, and t is equal to degree of freedom is equal to 6. That is equal to degree of freedom is 8 minus 2. So this is 2, and you know that you already know that this is also a degree of freedom n minus 2. Okay, now you can calculate the rejection region. I will explain in Python. That is very simple, but the procedure behind that is explained here. Now you have two side hypothesis, two tail test, one this and this one. So this means that you have alpha by 2. Degree of alpha by 2 is 0.025. So this is now alpha by 2, and degree of freedom is 6. So if you see the table for 0.025 and 6 degree of freedom, you will have this value. On the left tail, this is minus 2.447. In the right tail, it is 2.447. Yeah, this is symmetric distribution, so the values are similar, but with the different sign, remember. Now, you need to calculate that statistic using the same formula as I mentioned, on the website. With this significance level and this degree of freedom, and the correlation coefficient is 0.9129, you need to take a square and divide by this. So this is the value. Remember, region from here, the green region here, and the yellow region, I think this is the blue region here and blue region here. These are rejection regions. So if the value is greater than 2.447 or the value is less than minus 2.447, we reject the null hypothesis and conclude that there is no correlation. The correlation is zero between the two variable, whatever the variable or. So look at this. This value is 5.47, and this is far higher than 2.447. So this means that we reject the null hypothesis and conclude that there is. This means that okay. Okay. We reject. Remember that there are two things which are very important: the null hypothesis and the significance level. The significance level determines the rejection region, and the null hypothesis can help you in the decision. So we reject the null hypothesis, this hypothesis. So what does it mean by this? This means we accept this hypothesis, and this hypothesis means that the correlation is not equal to 0. There is correlation. So then you can explain, you can interpret the results of the test. So you need to know these are very important things. So at 5% level of significance, which is this one, there is enough evidence to conclude that there is a significant linear correlation between advertising experience and company sales. So this is about these two variables. And if your data is about co-curricular activities of the student and CGPA, you can interpret in that way. So if you reject the null hypothesis, this means there is correlation. And if you accept the null hypothesis, this means that there is no correlation. So this is all about theoretically. Now let's move to Python, that how we can do this stuff. Let's open the file. You can, okay, you can go back. This file open, and no, and this is not my file. Significance. Okay. Okay, and this should be here. Okay, here you will find it. This one. So open this. It's a very small code, so you can run this very easily. You need to two libraries, NumPy to make these arrays, and then this py that states import Pearson. We are using linear correlation testing, so the other maybe sometime next time. And now this, and then you need to create two data sets. Remember that you have your you may have your own data set for two variables, or maybe you can use from online sources. So you need two data sets. This is bivariate analysis. Suppose x and y. So this is data x, data y. And remember that we calculate the Pearson correlation coefficient and p-value. So remember that we are using this command Pearson here, and for x and y, and this will store correlation coefficient, and this correlation coefficient will have the value of the correlation coefficient, and p-value will store the p-value from this Pearson command, from this function. So just run this. Okay, so now we have run this. You can now display the results. So print, and now this correlation coefficient, this will be printed as it is, and correlation coefficient has the stored value from this test for this data. So this will print the value like this. Correlation coefficient. So this is print as it is, and this is the correlation coefficient value stored in this correlation coefficient from this test for this data. And similarly, you can display the p-value. So the correlation coefficient is 1, which is perfect positive correlation. The p-value is 0. So this means that we reject the null hypothesis. What was the null hypothesis? The null hypothesis rho equal to 0. There is no correlation. So we reject this hypothesis and accept this hypothesis that there is a correlation. And of course, there is a correlation. Okay. So this is all about how you can test. Very simple. You can use Pearson as the command, the function, and you can store the values here in this, the correlation coefficient, and here the p-value. And these are something, test of significance. Alpha is equal to 0.05. If p-value is less than alpha, print correlation coefficient is significant, statistically significant. Something like this. Okay, not like this. You can do this the whole. See, so this is not important because you know these things. Important thing is until here. So I think this is enough for today, and I will summarize what we have done. We have done that how we can test correlation coefficient, and what is the procedure, what is the test statistic, how we can do this, and how we can interpret the results, and at the end, how we can perform this in Python. Thank you very much, and see you in the next video. Ciao.